Hi, I'll go over lab 3 of ECE 286, which is AC circuit analysis techniques. So part 1 or experiment 1 goes over superposition. You have to measure the voltage drop across all the elements in the 3 circuits depicted right here. So for my resistors, I swapped them out for 3K. So the results that I will be showing will be different from what you will be getting. So I have set up this circuit. The 3 circuits are pretty similar to one another, so I'm only going to do one of these circuits. So let me pull this up. Okay, so here is my middle 3K resistor. My green cable is my power supply. The black cable is my ground. Here's the other 3K that's on the left branch. Here's a capacitor, the 100 nanofarad on the right branch. Channel 1 will be measuring the input voltage. So there's the solid orange connected to the same node as the power supply, and the negative terminal of that channel 1, the orange with the white line, is connected at where ground is. And then channel 2 will be measuring the voltage drop across the resistor by itself and the capacitor, the 2 parallel branches. So this is where my channel 2 is measuring. So that node right there, and then across ground. So I will open up Scopy. There we go. Okay, connect to it and give it a moment. So we want to input a voltage of 1 volt at a frequency of 1K. So I'll just go to signal generator, just go through this. I'll just make it 2 because since it's 2 peak to peak, and I said 1K, so let's get it to 1K. Okay, we're outputting that, and then now let's click single. And we need to adjust this, increase the time base and collect more data. There we go. Okay, so then we just want to measure the max voltage. So if you click on that little blue box to the left of measure, you'll get the max voltage. So as expected, channel 1 is measuring the input voltage, so it's 2 volts, and then channel 2 is measuring that voltage drop across that resistor and that capacitor. Again, the resistor that I use is different from the resistor you are supposed to use in the lab. So that is why you'll see a difference in your voltage for channel 2, which is the voltage drop across the parallel branch of the capacitor and resistor. Okay, and then you do this for the other 2 circuits, and that's essentially experiment 1. On to experiment 2, you have a complex superposition circuit. Give me 1 moment to set up my circuits. Okay, so here's my circuit. Actually, give me a second. Cool. Okay. So here's 2 parallel branches of capacitors. Oh, well, I wouldn't call this parallel. So that's the first capacitor, that's the second capacitor. And then if you see that capacitor connected from this point to this point, that's my capacitor that's connected across those 2 capacitors. And then these are the 2 resistors right here that should be grounded. So that's my ground, that's my voltage supply cable. And my channel 1 is measuring that voltage drop across this capacitor. I'm sorry, this resistor right here. That's one of the measurements you need. And then any of the capacitors. And that's the other measurement you need. And you just want to measure the maximum voltage across them. And you want to measure both of these circuits. I'm only doing the one on the right, but you can easily do the one on the left yourself. So you're going to measure, you're going to input actually 1 volt with 3K as a frequency. And then for my demo, all these resistors that I did use are 100 ohms, so you will get different results. So now let's go to Scopy if I can find it. Cool. So Scopy, make sure when you do switch, you turn off your power supply. So 3K, nope, 3K, and then I'll just go to my oscilloscope and then click single, collect some data. Beautiful. Okay, wow. So channel 1 was the voltage drop across that resistor in between the capacitors, and channel 2 was the voltage drop across one of those capacitors. So you could see that channel 1 is very low. So yeah, that's how you do experiment 2. Then now experiment 3, you are just doing a source transformation, but since we can't do a constant current source using the M2K, what we're doing is just a voltage source. And so this is a fairly simple circuit, and the two versions, there's one called NLab, and then there's going to be a different section down here called 82. It'll say 82 plus M2K. But it's the same thing as the NLab version, but you're using a lower voltage. And you are supplying a 4-volt AC source, AC sine source with 920 hertz, and you initially have 3 elements in series with one another, which is a capacitor and 2 resistors, 2 1K resistors, and 100 nanofarad capacitor. When you measure this, you're just measuring that resistor across the voltage across that load resistor, which is between A and B. When you do the source transformation, you're still measuring the voltage drop across A and B. But now instead of having a a constant current source, we're just going to use a voltage source right here. So if you follow this along, initially you're supplying 4 volts at 920 hertz. You're still going to keep the same frequency because voltage across these elements that are frequency dependent will change because they are frequency dependent. So if you follow the math, there's a good bit of math, but it will show you what circuit you need to use to supply the voltage for your second circuit, which is 1.5 volts at 920 hertz. I don't need to really show you this because this is fairly simple, which is you just use the, oh, it disappeared. Where is it? Scopy, let's see. Yeah, so you see a signal generator, and then you supply the initial 4 volts, and then you did the second set, which is the 1.54 volts at 920 not kilohertz, but 920 hertz. There we go. That's how you just do it. And so, yeah, this is fairly simple enough where you just have to build a circuit and do the measurements. Good luck.